welcome back to this week's video, and today we're gonna go over radical and exponents, but mainly what we're gonna focus on is we're gonna focus on some little tricks and some rules. And in all honesty, the reason why I'm doing a second video on radicals and exponents is because I've been hearing from other IM2 students that radicals isn't really something they understand too well. So obviously I was like, okay, then let me make a further in-depth video. So first rule that I want to get out there, I put it in the last video for IM2, but I just want to emphasize it once again. I'm just going to write it out and then I'm going to explain it to you guys. What exactly does this mean? Okay, so here we have x to the power of a over b, and then the b root of x to the a power. So this is literally just a basic formula that if you memorize this, you will have at least a good solid foundation when it comes to. And this rule, it is so crucial because if you have this memorized, or at least have an understanding of this, or have a way to remember it, you honestly are halfway through understanding radicals and how that how radicals relate to exponents. But if this still looks a little confusing, you're like, Mariana, I don't know what this means, I need some examples, let me show you guys. So I'm pretty confident that you guys have all seen this. This right here is a square root. So here's what's actually going on that most people don't actually write out, but what's here is actually a 2. Actually, let me write that in a different color just to emphasize that it's kind of hidden in a way, if that makes sense. That's also too light, I'm so sorry. Okay. Okay, so there's a 2 right there and a 1, right? So this is what it isn't ever this explicitly written out, because it's just common assumption that this is a square root, right? We're taking the square of that. So if we were to turn this into radical form, it would write x to the power of 1/2, right? And the reason it writes like that is because we are using these rules up here. So that's exactly what these rules help you determine. Now, I'm going to show you guys a quick little trick of what helps me remember where does the A go, where does the B go, because for me, that was the thing that I struggled with the most during the time of my math career where I was learning about radicals and exponents and how they related to one another. So this might not work for everybody, this just works for me. And I thought it might be a little bit helpful to show you guys. So what I like to think is B, I think B on bottom, right? B on bottom. And so the number that's on bottom, we say bye-bye to it. And I know you're like, what even is that? What does that mean? That sounds so silly. When I mean bye-bye, my thought process is it's going to go outside the radical. And actually, before we go any further, let's do some quick little vocab review. This is a radical expression. So this is the radical expression, this entire thing. Specifically, this little symbol right here, this little guy, that's a radical. And this right here, this B, is also known as the index. Okay, I don't actually know how to say this, but this right here is the okay, let me know. Okay, so I don't actually know how to say this confidently, but that's what this is, the radicand, possibly something like that. So that was just a quick little vocab review just to make sure we are all clear on that. Let me go up and just erase the rest of this. Okay, now we're here. So my thought process, right? I'm going to keep this in mind. Whatever on the bottom, we're going to say bye-bye to it. So let's say I'm given the exponent x to the power of 2/3. Now, this number right here, this 3, is on the bottom. So I'm going to say bye-bye to it. And I'm trying to turn this into a radical, right? So I'm going to write my radical symbol. And I'm saying bye-bye to this 3. So the 3 is going to go right outside because I said bye-bye to it. And then inside, we're going to keep that as our radicand. And then we're going to just keep our a with the radicand. Just keep it the same thing. Oh, wait, sorry, that was a 2. But yes. That is my little, trick that helps me remember it. It's just I say bye-bye to the bottom number, and it goes outside the radical. So here's a different strategy that sometimes I will use if I, completely blank out, if I forget everything. It's, kind of silly, but this is, the trick that I use. Okay, so I write out, most of the time, when I take a test, all I can remember is this. That's sometimes, the only part I can remember. So, another example that I'm going to show you guys is just another trick. If that doesn't work for you guys, here's another one. So, let's say I'm given, if, I'm taking a test, right? And I'm nervous, and I'm, freaking out, and I'm like, oh no, I don't remember how to turn exponents into radicals, or vice versa. Let's say I'm given x to the 5/2 power, right? What I remember is that this just gets rotated. I know that might not make sense right now, but what I like to remember is that this gets rotated. And that's what helps you write it as just like that. I know for a minute that might seem a little bit confusing, but what I actually like to do is I like to physically put my fingers to the paper and then just rotate. So another example, let's say I'm giving, so let me use another example with the same strategy. Let's say I'm given the radical expression. Here's what I'm going to remember. Let's say if I were just to circle these two little numbers. Okay, so I didn't want to circle these. Okay, anyways, just know, let's pretend we don't have that. Let's just pretend we just have the 3 and the 2 here, right? What I'm going to do is I'm actually going to grab this. I'm going to rotate this way. I know, at the moment that looks funky. But that's also just a last minute resort. If you completely forget the rules, I just like to remember that when it's x, we're going to rotate these this way. When we're already given our radical expression, I just like to pretend those don't exist for the moment. And then I just, oh man, why is it grabbing all of them? Okay, then I just rotate. So those are my 2 main things that help me remember this rule right here. I will say, please, please, please remember this rule. It is so incredibly crucial, especially in the later maths that you get into. This is a huge foundation. I'm currently in pre-calc and we still use this to this day. So it's really important that you guys get a solid foundation of these kinds of rules. Alrighty guys, so this is the next rule we're going to go over. All this is saying is that when you're given a negative as your exponent, you are going to flip it over and do its reciprocal. So, for example, I hope you guys know that, let's say 1 of x, right? Or actually, let me use a different number. Okay. Before I even start that, let me go over something I hope you guys know. So, let's say you have the number 2, right? There's a known assumption that this can also be written as this, right? But obviously, we don't write that because it's really unnecessary. The reciprocal of this is 1/2, right? The reciprocal is just the denominator and the numerator swap. So what's going to happen when you're given a negative exponent is that you are going to give its reciprocal, but when you give its reciprocal, this little negative sign is no longer there. By flipping it and doing its reciprocal, you kind of take away this little negative symbol. And it's just a rule that is super crucial to know, because if you're given x to the -3, this can be rewritten as 1/x to the power of 3. Because we can also imagine that there's a number 1 under here, right? So, by doing its reciprocal, we are able to get rid of this negative exponent. And that is super, super important because, oh my goodness, especially when it comes to solving more complicated problems such as, okay, as you guys can see, okay, this is like not a real problem and we're not actually gonna solve this one, but you can see kind of how complicated this looks, right? From a first glance, you might be like, OMG, there's so many numbers, so many exponents, but really, it's a lot simpler than it might seem. This main rule, I honestly don't have like a cute little like strategy to like remember this, but it's just knowing that whenever you're given a negative, we're gonna pull this guy all the way down. You can either think we're gonna pull this guy all the way down, as in we're gonna pull it down to the denominator, or you can think of let's flip it and get it to its reciprocal, but once it's in its reciprocal, we get rid of that negative. So by doing that, we are able to actually solve for it more accurately. And also just like a little bit more explanation, what you're doing when you're actually given a negative exponent. So let's say, for example, x to the negative 2, what you're actually doing, right? We can rewrite this as its reciprocal, so it's just going to be 1 over x squared. And what this is literally saying is you are doing division almost, right? Because you're multiplying by its reciprocal, you're multiplying by its reciprocal, which is literally division, right? Because we've seen with lots of like algebraic equations, we have 1/2 x plus 2 is equal to x. What are we going to do? We're going to multiply by its reciprocal. Let's pretend there was a 2 there and a 2 there. What that does is it cancels this out right here and leaves us with 2x. Another quick example is, let's use the same equation, similar equation. What we do here is we divide both sides by 2, or you can also say we're multiplying by 1/2, right? So really all I want you guys to remember is this main rule right here. When you are given a negative exponent, you can do its reciprocal, keep that radicand the same, and just make sure you take off the negative symbol from your exponent. And that was really like the main rule I think is super important. And the next rule we're going to go over is combining the first rule with this rule right here. Okay guys, here we have a new little rule that I want to go over, or not so much, it's more of understanding how the two previous rules go together and how you can use that to solve. Well, what are you using these for? Well, you know, let's say we're using this at the moment to get a good understanding of the relationship between exponents and radicals. Yeah, instead of saying like, oh, to get a good grade on your test, let's focus on understanding and really building a solid foundation of understanding math rules and how they work. Okay, so how exactly are we going to rewrite this, right? Because we now know that anything to the negative exponent, right, is just its reciprocal. And this little negative symbol cancels out since it's on the bottom. And we also know that x to the power of a over b is the same thing as saying the b root of x to the a power, right? So we know these two rules, right? Because we just went over them. At least I hope you learned from those like other two examples. We know this, but this time we combine them both, right? So here's what's gonna happen. First things first, we're gonna work ourselves outwards, as in we're gonna start right here and we're gonna work our way that way. Firstly, we know anytime we see a negative exponent, what are we gonna do? We're gonna get to its reciprocal. We're gonna get this to its reciprocal. Okay, we're gonna get it to its reciprocal. So, what we're gonna do? 1 over x, and we're gonna keep this exponent for the moment. Oh my goodness! Okay, we're gonna keep this exponent just for this like little moment. So it's gonna be x to the a over b power, but we also know this can be transformed a little further, right? If we have x to the ab power, we can rewrite this as the root of x to the a power. So what are we going to do? We're going to do exactly that, right? Right now we have x to the a over b power. We're going to simplify this even more. It's now going to become 1 to whatever's on the bottom. We're going to say bye to it. So it's going to go outside the radical. B to the x a power. So this, the way we would rewrite this little guy right here. I'm going to erase all of this. I'm sorry, guys. Okay, so the way we're going to rewrite all of this is by saying 1 over the b root of x to the a power. Now, maybe that's a little bit easier to understand. Maybe it's not. I'm not really sure. So just to make sure it's like really like getting in there and you're really understanding it, I hope, I'm going to do an example with some numbers. So I'm going to do x to the negative 1/2 power. Okay, first things first, we're going to work our way out. So we're going to work our way out. So we're going to start right here, then go here, right? So first things first, I see it's a negative exponent. What am I going to do? I know I'm going to have to do the reciprocal of that. So it's going to be 1 over x to the 1/2 power. I also know that this is a fraction, right? So since it's a fraction, I can also think of it as a over b. This bottom number, x to the a over b, this bottom number goes bye, so it's going to go outside the radical. So it's going to be 1 over, what's that, bottom number 2, 1 to the square root of x to the first power, and that can be simplified even more to just say 1 to the square root of x. So really the main thing is understanding how you can use these rules and put them together and what the relationship is between them. So just as a quick review before we end off this video, let me go over like a quick run through of all these rules. X to the a over b power is the same thing as saying the b root of x to the a power. This number on the bottom, we say bye to it, right? So it's going to go outside this radical. If we're trying to turn x to the ab power into a radical, the b bottom, say bye. It's going to go outside of the radicals because we said bye to it. We keep this a, x to the a power, right? Even cleaner, let me rewrite this one more time. Second rule, if we have a negative exponent, we are going to do its reciprocal, and by doing its reciprocal, we cancel out this negative and we are left with this right here. We are left with its reciprocal and we no longer have that exponent as a negative. Lastly, if we are given something such as negative a to the b, first things first, we're going to work our way out. So we're going to start from the leftmost symbol, and then what we're going to do is we're going to turn this into its reciprocal, correct, because it's a negative. Okay, so now we're going to work our way outwards. So we're going to start off with this little negative. When I mean we're going to work our way outwards, I mean we're going to start to the leftmost of this little section right here. And since it's a negative, we're going to do its reciprocal. So we're going to have 1 over x to the ab power. Now, we also know from this first rule right here that we can simplify this even more. This now is going to become, we're going to say bye to the b, and it's going to go outside the radical, 1 over b root of x to the a power. Alrighty guys, that is it for today's video. I hope you enjoyed.